Sahiti, Triveni, any clarifications?
No, Ravi.
No, I'm good.
Okay. Okay. Yeah. So let's talk about the inheritance. Yesterday we discussed on the encapsulation, polymorphism, and abstraction. So we'll talk about the inheritance today, and then we'll slowly jump onto the collections. Okay. So yeah, encapsulation is basically hiding the data. So by providing the private variables and creating a setters and getters in order to set and get the data, whereas abstraction is going to hide the implementation. So the pure abstraction is possible with interfaces. Even abstraction is possible with abstract classes as well, but it will have both abstractions and concrete methods both. And the polymorphism. So whereas we will have both overloading and overriding. So overloading and overriding. So whereas overloading, same method with the different parameters. That's nothing but the overloading. Whereas overriding, same method and same parameters. If you want to override the features or change the implementation or override the implementation, so we are going to use the overriding concept. So now let's talk about the inheritance. Whereas inheritance basically inheriting the features from the parent to the child. So for example, you have a parent and you have a child. So basically the child is going to get the features from the parent. So that's nothing but the inheritance. Let's start with the example and then we'll talk about in detail. So how that is going to work. So I'll create as a parent class and the child class. So let's say parent, and I'll also create the child. So child, which is extends the parent. Okay. So let's say parent has some of the features and you wanted to inherit the features from parent to the child. So yeah, nowadays we inheritance, so we don't use much, but there might be cases where we use the inheritance. So that is also kind of the base and the child. The sub implementation. So it's similar to the parent and the child implementation. So let's say you have a color method, public, let's say void color. So let's pass some parameter here, string color. So let's say, okay, so I am, and then append the color. So this is the string and we are appending this particular string, the color string here. So now go to the child method. Okay. Child is just extending the parent. So I'm not writing any implementation for the child. So child also inheriting the same features from the parent. Now let's create a main method for the child main. So I'm creating a separate class. You can also create a main method in the same class also. So let's create a main method. So now we need to validate whether the child is inheriting the features from the parent or not, right? So first let's create a parent object. So parent object equal to new parent. So parent dot color, let's say white. And next create the child class, child equal to new child dot, so the color. Okay, so now let's say brown. So the another one. So this one we are saying, so we are just creating the child object directly, and this one we are creating the parent object. Since this particular child is inheriting the features from the parent, so we are able to get this particular color method. Okay. So if it is if the color method is available only in the child, then parent cannot get the feature from the child. Only the child can get the feature from the parent. Okay, so that is the main thing here. So when you go for the interview, they might ask this kind of a question. So I have a parent class, and the parent class has a public method, and the child class which extends the parent, it doesn't have any methods, and they will write this kind of code: parent equal to new parent and parent dot color. So which is the white, and again, so you're going to create the child object. Okay, so this is one, and the another one. So child one equal to, so new parent, right? So here meaning, so this particular parent cannot get the features from the child. So we are creating the child reference and the parent object, correct? So you have to say that this will give a compilation because so the parent cannot, this parent object. So object is the parent and the child reference, meaning so this parent cannot get the feature from the child, right? So you have to say this will give the compilation. So the other way, so parent reference and the child object. So this is a possible because this particular child can get the features from the parent. That's what it means. So now parent one dot color, right? So now, so here the only thing is the child can get the features from the parent. This is a possible. You can also create an object to the child because child already got the features. So the other way, you can also have the parent reference and the child object. But child reference and parent object cannot be possible as the parent cannot get the features from the child. Okay. So let's say I'm going to manipulate a little bit. I am parent and this one. Okay. Let's run this. After that, we'll manipulate a little bit and see so how the response is going to be. So you can see the response is from the parent, and the color which we are passing for the parent object is the white, and the child object, it is the brown. And again, the parent reference and the child object is the white. So now let's create the same method for child. So I'm going to override the same method for the child. Okay. So public void color and string color. Okay. So this string color is nothing but the method parameters that we are passing. So hope you remember the setter methods. Setters are different since you wanted to set the data. And this is our own method in order to have some kind of a behavior or some functionality. Maybe I want to indicate what is the parent color or what is the child color, right? So that's the reason I created a method. I wanted to pass my own data. So dynamically, I should get the color, right? So if you want a static, you can directly hard code it, but it doesn't make sense in all the cases. So you cannot reuse the same method, right? So that's the reason I'm going to pass the string color as the input. Okay. So this method parameters are nothing but an input. So one thumb rule in the real time, don't create too many method arguments. So there might be cases where you might need to pass a multiple parameters. That is not the recommended approach. So recommended is 6 or 7 parameters in the method. Okay. So like this. So string color, let's say int ID. Okay. String, let's say name, string description. Okay. So let's say string remarks, double price. Okay. So let's say a boolean is true. Okay. So it's not recommended to pass so many parameters. The reason is, let's say if you are increasing this method parameters, maybe some 20 parameters, it doesn't look good. And so you will have to pass all the 20 parameters, right? So even though it may not be needed all the cases. So that's the reason what is recommended is, rather than creating these many method parameters, you create a separate object. Object is nothing but separate class. Let's say instead of creating this, so you can also create a class here, another class. So let's say class, some let's say data class. Class name is a data. Okay. So this way is recommended. And you pass this object here. How to pass it? Data, data. Okay. So this is nothing but it's kind of a inner class, and this class will not be available outside. So this way you can do it. Okay, I'm just giving an example. But anyway, so when we talk about the Spring Boot or the real-time application, we'll talk about all these scenarios will be covered there. Okay. So this core Java is just to understand all the concepts and the different features and how we are going to use the features. But in the Spring Boot, you will see the real time examples. Okay. So this way you can create it. And you can create a setter getters and again to set or get the data. Okay. For all the data classes, definitely we'll have a setters and getters. Okay. So the recommended approach for this kind of scenario, this one. Okay. So yeah, now let's take a string color. Let's go back to our example. So the string color, and I'm going to create a sysout method. Sorry, sysout. I am child and color. Append the color. So we are going to append the color to this particular text. Okay. So in real time, so we don't write a sysout. What we do is maybe we'll have some business logic here. Okay. Yeah, let's make it as a kind of a real time method. So rather than the void method, let's return this particular, you know, what you want to return for this particular color. I wanted to return as a string, the return type. So rather than writing a sysout statement, return I am child and color is this one. Okay. Yeah. So now let's go to the parent. Okay. Parent also, let's modify this. Right. So now this method doesn't have any kind of sysout statements. Even the child also doesn't have any sysout statements. All right. So now you cannot print it. If you run it, you will not be able to print anything. Okay. You will not be able to print anything here. So now what is that we need to do here? So we need to write a sysout. Okay. Sysout. And so this color is going to return the string, right? If you just mouse over on this print, parent dot color, so which we are passing the white, so which is returning a string. You see here, right? So if it is returning a string means you will have to return the value string. So the parent color or something, you can assign some variable and print this variable for your testing. Okay. So don't, yeah, you can also directly copy and paste this one here, like this also. But it's not recommended. So create a variable. Okay. Since this particular color method is going to return the string as the response. Okay. So similarly, you create this one child color. Okay. So this one, so the parent, is the child inherits the features from parent. Okay. So inherit color. Okay. And then print this one. Here also, let's print it. Right. So I'm just printing all this data. Now let's run this. See, what is that we are trying to do? The same thing. I'm just in the color method, which is going to return the string, and I'm assigning a variable for it and then printing that. So even for the child also, I'm doing the same thing. Even for the parent referent and child object also, I'm doing the same thing. Now let's run and see the difference now. What is the response that we get? So now parent and child has the same method, but the written data is a different for both of them. If you see, the parent has a I am parent and the color, right? And the child has I am a child and color, right? So now if you see the difference, previously everything is I am parent and the color. That is what the response that we were getting. Now the response is changed to the, for the first statement, we are getting I am a parent and white. And for the second one, the child object is getting the response we are getting, I am child and brown. For third one, so the child parent reference and the child object, we are getting again, I am child and white, right? So if you carefully observe this one, right? So if you do the deep analysis, so since it is a parent object, so we are concentrating, only the parent, right? So that's the reason we are getting the parent response. Second one also, it makes sense because we are creating a child object. Okay. So we are creating a child object because the child is overriding the features, right? So that's the reason we are getting the child features. Third one, even though it is a parent reference but the object is a child object, right? So we are again overriding it. So that's the reason we are getting the override method response. Any questions here? So this is very important to even interview questions also. Okay, to make you confusion, so they will write this kind of example and they will ask, so what is the expected response? Or when you do some online test also, you will see this kind of example for the inheritance. Any questions? So they will confuse you here, most of the cases, this one. They will write like this. So child, and child one dot color, right? And let's say red, right? So first of all, this is a compilation. So the compilation fails at line number 13. Okay. Any questions? All good? Not sleeping, right?
No, not
Okay.
sleeping.
Okay. Yeah. So yeah, this is very important inheritance. Okay. Yeah, it's most of the interviews they will ask this question. Yeah, for 3-4 years experience, or maybe 7 years, even if you have experience 15 years, also they ask this question. Okay. Yeah. Now let's talk about there are other data types called a proper data types. Yesterday we discussed on the primitive data types: int, char, boolean, float, double, long, byte, short, right? Yesterday we discussed on those data types. Let me open a text editor. Okay. So we discussed on int, long, short, double, byte, float, and char, string. String is not a primitive, but I'm just giving it's also a data type. Okay, string is an object. So yeah, there is a different. We'll talk about the string separately. Okay. So int, long, byte. Okay, boolean is missing. So boolean, right? So these are all the data types. And by default for for these the values will be integer 0, long 0, short 0, double 0. Byte it will be Unicode character, and for float it is the 0.00. Yeah, even double 0.00. And character also it's empty character, and for boolean it will be true or false. Sorry, false is the default for the boolean, right? So now here, these are just the primitive data types, meaning the memory allocation will be different for the these. Okay. So generally the memory allocation will be less for the primitive data types, but you cannot use the primitive data types in all the cases. Maybe assume that there are cases where the data can be, let's say, I'm going to take as a int, right? Okay, int I equal to 0. Okay, right, in mathematical, so even 0 has a value, right? So let's say we are saying that you're highly talented, you will get 100 marks. 100 marks. Maybe other guy maybe is a 0. He doesn't know anything. Okay, so maybe you're getting a, we are saying so is a 0, right? Generally, we also have a negative marks and all, right? In some cases, some of the exams. We'll say that is real a waste, and maybe, I mean, I don't know whether this is possible or not. I'm just saying so. Negative marks is really not up to the mark. So we can give -10, right? Means, so definitely that is what the mathematical rule, right? We'll talk about. So 0 and -10. Let's say you're not even attempting the test. You're not writing anything. You didn't even attempt. You have given just a white paper back to them. Means you didn't attempt anything. Means null. Right? Null. So for int, it's a primitive data type. Primitive data type doesn't allows the null value. It doesn't allows the null. Okay? Because primitive is not a object. So if you want, you can search it. Okay. Shift Control T means type the classes. Okay. So int type just lowercase int. See, this is a different. This int is different, right? You never see anything, right? There is an integer, but not the int. Okay, int is the primitive data type. So for this, the corresponding objects are the wrapper. Okay, we call as wrapper data types. Okay, the wrapper data types are integer. Okay, long, short, double. D is the capital. You know, right? The class, the fundamental rule. So the first character should be the uppercase, right? For int, it is an integer. For long, it is a long. For short, it is the short. For double, it is the double. For byte, it is the byte. Sorry, byte. And for float, it is the float. For char, it is the character. Okay. For a boolean, it is the boolean. String, that's nothing. Same. Okay. So these are the corresponding proper data types. Okay. So why I'm talking about all these things is, so generally the data, for example, you want to assign the data from I was talking about yesterday, the Gmail registration, right? So the recommended is the primitive. There are cases where you wanted to have a null. If there is no value assigned, you just want to define as a null, then you can go for the proper data types. Otherwise, always define the primitive data type. Okay, so that you will understand when you write the real-time application. So what cases you have to define a proper data types. Otherwise, always recommended to go with the primitive. Understand, right? So because I was talking about all these things because in case of the collections, so the collections doesn't allow this primitive data types. Collections doesn't allow the primitive data types. So it allows only the proper data types. Okay. If you want to know the memory consumption for both the primitive and proper, let's okay. So integer versus integer. I want to show you the, yeah. So even this one, right? Integer, it's 32. This is int. This is for the primitive. Where is for the proper difference? Let me show you. Yeah, you see here. So the memory allocation for this. So the primitive data type, it takes only the 4 bytes. Okay. Whereas the proper data type, it takes 16 bytes. See, it's almost 4 times higher. Right? So that's the reason. Unnecessarily, don't create the proper data types until it is required. Okay. If it is if at all, if it is required to convert into the proper data types, okay. So during the collections, what you can do is you can do the something called boxing and auto unboxing, auto unboxing. Okay, auto boxing, converting from the primitive to the proper, auto unboxing, converting from proper to the primitive. Okay, so the boxing happens, it's automatically. So what you can do is, if at all, if you want to convert it integer, in equal to, so you can also create as a new integer and then pass that value, whatever the integer. This is one way. The other way also, integer, you can do the typecasting. Okay, so this is nothing but the typecasting, converting this int to the integer. Okay, auto unboxing, it happens automatically. So int I equal to, you can define whatever the value that you are getting from the wrapper data type. Let's say you're getting 10. So that's nothing but let's say in. Okay, so that I'll show you in the examples. That's easy to understand. So just try to understand. See, auto boxing and auto unboxing, that's another terminology during the interview they might ask. So the conversion between the primitive to proper and the proper to primitive, that's the auto boxing and auto unboxing. Okay, so now let's slowly jump on to the collections. So the collections, in order to store any kind of a data or in order to process any kind of a data. So in the day-to-day activities, we are going to use the collections. Okay, collection is a different and the collections is a different. Collection and the collections. Okay, we'll talk about this in a while. So first, let's talk about what are the different collections available and how we are going to use them in a day-to-day activities. Okay, so assume that you want to have some set of data. Okay, so let's say you want to define all the students list or all the employees list in the organization. Okay, so you want to define an employees list in the organization. So I have an employee class. It may be the public class employee. So the employee has an ID, private, int ID, and private string name. Let's say private string department, private string, and employee address. So maybe the address also can be another object. For now, just take it as a string. Okay. So private int ID and the name of the department and the address. I wanted to store this information. Maybe I want to store this information into the database. Okay. Right. So I want to store this information into the database. So how to store it? Right? If it is a one employee, that's fine. So you're going to store one by one employees. Now, so while creating it's only one employee you can create. Or there are cases, maybe if it is the employee is created by the admin, so definitely the admin cannot create a one by one. It's going to take a long process, right? Sometimes what they do is they will give you a plus option, one employee and second employee, and then submit all at a time. Or sometimes they will have an Excel sheet, just to dump that Excel sheet into the DB. It's easy for them to enter, right? So just they will create some kind of the Excel sheet with all the data. Let's say employee ID, and name, department, and the address, right? So let's say one, let's say Ravi, department IT, something. Okay. Let's say address. So what they do is just they will upload this Excel sheet into their system. Their system is nothing but, so basically the application could be any Java or any other programming. Okay. So they will give upload feature. So when they upload, it reads all this Excel data and convert it to the list. It's a list, right? Basically the list of data. Okay. It's a collection of data. It is not a single object. So if it is one, then we call as object. So if it is more, then we say it's a collection of data, right? So the collection means, so when you want to store the data, the collection of data, then we are going to use the, you know, the collections, the list of data. We'll talk about, there are other collections. Okay. So now assume that you want to store this. How to store it? So we have to take it as a list of employee. It is a list of employee. List is one of the collection interface. It should be the same. You cannot create a lowercase list. Okay. It is the list interface. Right. First, let's see what are the collections. So I just want to show you the image. Yeah. So we don't need all of them to discuss. We'll discuss only the few. Okay. So yeah, so this is the hierarchy for the collections. So you can see, so they're saying, so, this particular blue is the interfaces and the green is the classes. Okay. Uh, for now, let's ignore about the classes. Just let's talk about the interfaces. Okay. So the super, right, in Java, the superclass is an object. What is a superclass? Is an object, right? After object, you will have a iterable. Okay. Iterable we will discuss in the examples. And then the collection is an interface. Collection. So the collection which extends. So the interface can extend another interface. Yesterday we discussed, right? So the class can extend another class. Class can implement another interface. But interface can only extend. Interface cannot implement another interface. Remember this. Interface can only extend, right? So that's the reason. So here you see the difference they're saying. So dotted lines means implements. Straight line, it is the extends, right? You see here. So this particular collection which extends, list which extends the collection, queue which extends the collection, set which extends the collection. Okay. So list and set are the collection interfaces. As part of the collections, we also have something called a map. Okay. But map is not extended from the collection. Okay. So that's the reason they have not included as part of this diagram. So there are other diagrams. If you see, I think this one. Yeah. If you see this one, let me make it a little big. Okay. So I'll just, yeah, I'll open this one. Okay. You see here. So the collection, as part of the collection, we have a list, set, and queue. These are again the sorted set and DQ. Okay. And map and iterator. So we'll not talk about, we'll not discuss everything here. So we'll just talk about the collection list and set. Sorted set is not so important for now. Okay. And then we'll talk about the map and iterator and the list iterator. Okay. So first, what I will do is I'll create a simple example. Then we will see the hierarchy from the API. Okay. Before that, any questions? Any questions are on inheritance or primitive and the proper data types?
No.
Okay. Yeah. So what I will do is I'll create a simple example. So I'll create another package for the collections. Let's say com dot, sorry, we dot collections. Okay. So what I will do is I'll create a simple the list example. Okay. So you cannot create the list again. Okay. You can create it, but again, you will get a confusion. Okay. So that's the reason. Try to avoid creating the API classes, the Java library classes. So it's, the list which is provided by the Java library, right? That's part of, from now onwards, you should also remember the packages, from which package it comes from. Okay. So I'm going to create a main method for testing it. Okay. So let's take a list of integer. You cannot define a primitive now. See, it gives a compilation. Let's say numbers list equal to, okay. There are multiple ways of adding the numbers into the list, right? It gives a compilation. If you just mouse over, see, replace int with the java.lang.integer. So all the proper data types are the java.lang package. When you are writing the proper data types, integer, okay, you can see here java.lang package. We never import the java.lang, but for the list, it comes from the java.util.list. Okay. All the collections comes from the java.util package. And all the proper data types comes from the java.lang package. If something comes from the java.lang package, we don't need to write an import statement, as the Java by default, because even the object also it's the lang package. Right? You see, the object also, it is from the lang package. So why we write an import statement? Because for the other class, they have a package. The package is a different package. It's not in our same package, com.vera.collections. That's the reason that package we have to import it in order to get that particular object. Hope you are getting it, right? So here, for example, if you want to get a child class here, right? Yeah, let's create a child class in the different package. Child. See, the import statement is automatically imported here. Why? Because the child package is not in our package. If it is in our package, then we no need to import. Since the child is in a different package, we need to import it. Hope you understand, right? So when we need to import it, right? So now let's write the list. So meaning when you have these less than and greater than, see, E, I think it's a type basically, or entity. So element or something. Yeah, it may be element, I think. Okay. So E, and this one we call as a generic type. What is this type? We have to provide what type this particular list allows. can also define like this list. Okay. So if you see the legacy code in your applications, you might see this kind of a code: list equal to new array list. Meaning what? What list? What is the type that you are allowing for this particular collection? What list? Okay. We cannot create an object for list again. New list. Why? Any idea? Why we cannot create an object for this list? I'll just mouse over.
Because the list is interface. We can't instantiate for interface.
Exactly. Yeah. So the list is an interface. We cannot create an object for the interface. So that's what we discussed, right? So we cannot create an object for the interface. Okay. So that's the reason the implemented class is one of them is the array list. We have other, we'll discuss on that. So one of the class which implements the list is the array list. If I just define like this, I can add the data into this particular list, right? List of object. What object? Object can be anything. It could be integer, or it could be string, or it could be character, or anything, right? Let's say I'm going to add a number 1. List dot add, let's say Ravi. List dot add, okay, let's say some 10,000. List dot add true. It is allowing all the data types, anything. See, it is the integer, string, and boolean. Now let's try to print it. It will print. Okay, it will print. This is fine. It's working, right? Now the problem is, okay, I wanted to multiply this data. I wanted to multiply this data. Okay. We have, there is something called for loop. We'll discuss on this for loop in detail. Okay. For now, I'm just writing it. Int I equal to 0. There are many ways. So I'm writing the normal for loop. We also have the for each and other things. We'll talk about it. So I is less than list dot size I plus plus. Okay, we'll discuss on this one. Now I want to manipulate it. Sys out list dot, we have a get of index I, okay, into 2. Okay, into 2. See what it is saying? Cannot be applied to object comma integer. Why? Because this list we are not defining what is this type. So it is just object. If you don't define any type, it is an object, right? Or the other way, so list dot get of I, okay, and then let's say integer dot parse int. I wanted to parse, because there might be cases what we do is in the real time. So we'll write even this one as a double quote string, and then I wanted to parse it. But here it's giving a compilation. The reason is it is the object type. Okay, I'll show you one more example so that you will understand. Now it is the, even integer dot parseInt. I wanted to convert whatever it may be into the integer. Whatever in the sense, you cannot take the alpha, the characters, like a sequence of the characters, you cannot convert into the integer. But what I will do is I will define this as a string, list of string. Okay. What I will do is this one, I'll keep it in the double quote. It is integer only, but we are making this as a string. When you say double quote means it's always a string, even though it is a number. So we are converting this into the string. But even the Ravi is not a number. It is the, the characters, the sequence of characters. Even this one also I'm taking as a string, and 10,000. Let's make this true also as string. So now what is that we are trying to do? We are trying to convert whatever the value into the integer. That is where we have an integer dot percent or integer dot value of. So I wanted to convert that into the integer. So if you see, just a mouse over on this, right? See, this percent is allowing this string. Okay. Or again, if you remove and if you do control space, you see here. So the integer dot percent, which allows the string to convert into the integer. Right? Now let's try to run and see what is that. We get an exception. See here, it says number format exception. Okay. So at this point of time, you will not be able to understand the exception handling. We'll discuss on this later. For now, just see that. So where it is throwing an exception, you see, you have to see the hierarchy. Okay, where the exception is started. See, the exception is started at this particular class. You have to always check our packages. Our package, you can see com.vira.collections, and the list test is our class, and which line it is throwing an exception, line number 15. Why it is throwing? It is also giving the cause. For input string, it is not able to convert it to the integer. Why? You cannot convert this string into the integer. I mean, if it is a number, you can convert it, but it is not a number. Right? Let's make it as a 10. This one, let's make it as a 20. Now we can convert it. Right? So that's the reason always define what is the data type that you want to allow. But don't ever define like this, because again, the string and we have to convert into the integer. So that's not the recommended. If it is an integer, just to define an integer. So you have to remove the double quotes. Right? So this way you can define it. So now we don't need to do the integer dot percent again, because it's already integer. Right? So you can say list dot get off index. We'll discuss on this part. Okay. Just try to run it. So hope you are able to understand. So the list which allows only the integer, and the implemented class for this interface, the collection interface, is the array list. Okay. So if you see the older code, so you will see this kind of a code. Okay. So before Java 7, okay, so you will see this kind of a code. Still, a lot of people, they will write this kind of code, but it's okay. But it is not required again to define this. Okay, what is the type? Just to define the diamond operator. That's it. You don't need to define what is the type again, because this this particular class, the array list, which is going to implement the list interface, the list allowing the integer. So by default, this array list also allows the integer. Just to leave the diamond operator. Okay. So now if you run it, you will get the same data. So now, see, here also you are getting the data. See, Here also we are getting the data. So this one also getting the data, but this one has a toString method. If you go into the array list, no, maybe somewhere, yeah. So they're printing that the list, right? So if you go to the list, yeah, maybe some of the class it comes. So they are just printing that list internally. When you just write a list, it will have a toString, which is going to represent the response as the string format. So that's the reason we are able to get this particular data. The list is just printing it, right? But we are getting all the data at a time. So assume that there might be cases I was saying, right? So you wanted to, iterate the data. So when you have a collection, you have to iterate the data, and then you want to transform the data. So the example for the transform, let's say I want to multiply by 2, right? So, or maybe it depends on the data, you have to multiply. Let's say if the number is, okay, list dot, we'll talk about this particular part, get of index I is less than 10, okay, then multiply, else don't multiply. Maybe this is the scenario. Okay, so now if you run it, okay, so only the less than 10 value we are going to multiply. Less than, we are not even saying equal. You see here, 1 into 2, it's a 2. 10, 10,000 and 20. Okay, so now there are a multiple ways of iterating the data. Iteration, we call it iteration. Okay, iterating the data in order to get all the data from this particular collection, the list. So this one is just to print it. So now here to iterate, we have a for loop, for each loop, we have iterator, we have a stream API, that's the Java 8. We'll talk about one by one, everything here. So the first one, we use the for loop. Okay, so this for loop, it has a initialization. So meaning, so we start from the 0 index. So the list is it allows the index based. It allows the index based, nothing but the data, whatever that we are going to add into this particular list, it will have an indexes. Okay, let me paste it here. So first one is the 0 position. Second one, it starts from the 0 position. First position, second position, third position. Got it, right? So this list has the data indexed. Okay. So the data will be in order. So it will be index order. So 0 to n, right? So now in order to get the data from this particular collection, so we are going to, since I want to get a specific index, so we are going to define the starting from the list I equal to 0 and I is less than list dot size. List dot size means what? It takes the size as a 4. So this collection size is 4. Why? Because we added 4 times. But the index from 0 to 3. 0, 1, 2, 3. 4, right? You're getting it, right? So index starts from 0, but the size is 4. So that's the reason we are taking from the 0 index. And then I is less than size. Means I is less than 4. And then every time it's going to increment. This is nothing but a post increment. I will show you one example for the post increment, pre and post increment, then you will understand better. Okay. Post increment means after iterating, this will increment. Okay. So now, so it starts from the 0. Okay. Just to define 0 and I is less than 0 is less 0 is less than 4. I plus plus means now it will not increment. After this iteration, it will increment, post increment. Okay. Now list dot get of I. Get of I means what? Get of 0. List dot get of 0. From the list, get the first index. What is the first index? 1. So here it will be 1 is less than 10. True, right? 1 is less than is true, meaning it will go to this particular if condition. So 1 into 2 equal to 2. Now for the second iteration, so it is a post increment, right? By the when it comes again here back, it will come again here until this loop exit. I mean, the data iterated, it will go back again. Again, it will go back to this particular for. Now it will be 1. 1 is less than 4. All right. So now, so what is the index 1? Index 1 means it's a 10. This is the 0 index. This is the index 1. Index 1 means 10 is less than 10. No, right? It is not less. 10 is equal to 10. Means it goes to the else condition. So list dot get of 1. 1. Because now this index changed to 1, right? 1. What is the 1 position? 10. Again, it will come back to this for loop, right? So now this index will change to 2. Okay. 2 is less than 4. So now this one, it will be list dot get of 2. Get of 2 means what? 10,000. 10,000 is less than 10, which is false. It will go to the else condition. It will be 10,000. Now the next one, 3. 3 is less than 4. It's a fourth iteration, right? Fourth time. Because we started from 0, now we are iterating fourth time. It will be 3. 3 is less than 4. Right? So now list dot get of 3, which is the 20. 20 is less than 10. No, it is a false. It will go here again, 20. Now 4. 4 is less than 4. False. It will exit. You got it? Triveni and
Yes,
Sahil.
I got it.
Okay. Yeah, this is important, right? If you understand this one, it's easy to debug. Okay. So this is the, we call as a legacy for loop. The traditional way of creating a for loop. Okay. The older style of creating for loop. You can call with the different names. Legacy or older or the traditional for loop or normal for loop or whatever. Right? So this is one way of iterating this particular collection. Okay. So let's go with the second way. So what I will do is just for understanding. Okay. So traditional for loop or for loop, whatever. Now I'm going to, there is something called for each loop. Okay. So the second way, I'm going to use the for each loop. So we have something called for. See, in case of IntelliJ, when you're writing, it is asking, so what you want to go. whether you want to use the for or for each. Okay, when I say for each, it will give the syntax also. So what I will do is, so what is the data type? It is the integer. This particular list which allows the integer I or in whatever. Okay, what do you want to iterate? This particular list you have to iterate. This list, right? You see here, yeah. So in integer, and then what do you want to iterate? This particular list. So this particular list will iterate until you have the last element. So now if you just print it, you will get all the data in. So you have to print this particular integer. So every time it will iterate one object until the last element. So this is the easiest way of writing code, right? So if you want to write a condition here, if the in is less than 10, okay, print it, else just multiply by 2 in into 2. Right? So if you see, the response will be the same. Traditional for loop and okay, whatever. In is less than. Oh, okay, got it. Because by that time we are iterating, we are already manipulating. Okay. No, one second, something is missing. List. Let me just this in list and is less than 10, sorry. Yeah, here, right? So we are writing opposite. So into 2 and in. And let's uncomment. Yeah. Okay. So the condition was incorrect. Now if you run it, you will see the same response. Right? You will see the same response. Right? So first one is the for loop. Second one is the for each loop. Any questions as of now? Yeah, if you understand all these ways, it will be easy. Okay. So collections is easy only. So only thing you have to understand how we can iterate it. Any questions as of now? Okay.
No.
Now, yeah, now let's go with the other approach. We have something called iterable, iterator, not iterable, iterator. Okay. So iterator. So let's define what is the type. It is the integer. Okay. So this is the iterator. ITR equal to, so the list dot iterator. List dot iterator. Right? List dot iterator. So now when you are going to use iterator, we are going to use, there is something called while itr dot has next. Okay, has next. So which returns the boolean. See, returns true if the iterator has some more elements. Means the same structure, the same way it is going to iterate until we have the last element. If it returns true, it will iterate to the next element. Has next means it has a next element. And so when you are going to use the iterator, we have a has next and next methods. Okay. Now, if you want to get a element, itr dot next element. So when you have a next element, has next. It's a general English word, right? Has next. If it has a next element, go get the next element. So itr dot next. So now if you want to check the same condition, if itr dot next is less than 10, just multiply by 2. Else itr dot next. Okay. So this is another way. Okay. So we are not going to use all these approaches. Mostly either we use this one. There are cases where we use the for loop, but nowadays we don't use this iterator and all. Okay. Yeah. So now the other way, we have something called a list iterator. Sorry. List iterator. Okay. Integer list iterator equal to list dot list iterator. While list iterator dot, okay, has next. Same thing. Okay. You can copy the same thing. So the only thing with the list iterator, we have an option to iterate in a backward and forward direction. Backward and forward direction. Okay. So if you want to get the previous element, so we also have the has previous and has next both, but we never used it. So if at all, if you want to try, so we have something called, I don't know how to, yeah, I never tried it. So has previous, and we have a previous methods. So if you want to iterate in a reverse direction, okay, from the backward direction, okay, you can use this has previous method. So the list iterator has both forward and backward direction. Okay, these are the different ways. So the next way, we have to use the Java 8 Stream API. So yeah, we'll take 10 minutes break or 14 minutes break. And then we will talk about the, how to use the Java 8 Stream API. Because I'm going to discuss both the, the collections and Java 8 features both together so that you understand. So, otherwise, right, it's very difficult to differentiate between the before Java 8 and after Java 8. Any questions as of now? So any questions?
No.
Okay. Yeah. Yeah. Let's take a break until 8 o'clock and then we'll continue again. Okay, then. Yeah. I'm going to pause the recording and I'll mute myself. Okay, let's start. Hope everyone is back. Sahiti, Triveni, Santosh. Hope you are back. Yeah. Okay. Yeah. Let's start again. So any clarifications before we talk about the functional programming, how it looks like, and how we can write the using the functional programming? Any clarifications? Okay. So yeah. So the for loop for each and iterator, it's easy to write it. Yeah, list iterator, if you wanted to iterate forward or backward direction. So we use the list iterator. List iterator, it works only for the list interface. not for other interfaces. Okay, so now let's see the using Java 8, how we can write using the Java 8. Okay, so yeah, Java 8, we have a stream API and lambdas, the functional interface, and other thing. There are some changes in the map interface, and we have some changes on the util, the date related. Okay, you will understand slowly. For now, just let's discuss on how we can iterate this particular collection using the Java 8 Stream API. Okay, and then we will discuss on the different features are available in the Stream API. Okay, so the same code with the Stream API using Java 8, how we can write it. So the list dot, we have something called stream. Okay, and then, so what is that we need to do? So if the list has a value is less than 2, then we need to iterate it, right? So we have something called filter. Okay, so we'll discuss on all these things in a while. So filter, so some value, the value is nothing but the integer value, or you can say in. Okay, so if, sorry, not if, so in is less than 10, if in is less than 10, then, so we have something called a map. Okay, we'll discuss, definitely will not be able to understand at this point of time. So map, so the map has it's nothing but for the transformation. Okay, in pipe, so this is nothing but a lambda expression. So now in into 2, and then for each system dot out colon println. Okay, so this is the Java 8 stream API. See, so with a single line, we are able to write the code. Okay, just run all of them together and test it. Okay, so here we are not getting all the data. Let's we'll discuss. Yeah, we have to change a little bit here. So this is not required. Yeah, so here I'll write okay. So let me run this again. Yeah. So now you can see the data, whatever that you see there, right? But here it's a little simple. I mean, the lines of code is lesser than the for loop or for each or while, right? So we'll discuss. So we have something called a stream, and then so if you talk in general, so whatever that you are writing in the if conditions, so that is nothing but the transformation. transformation, nothing but we are transforming the data. So when based on the conditions, right? So if the value is a less than 10 from the list, so we are multiplying by 2. That's nothing but the transformation. Okay. So similarly, in the collections, in the stream API is basically streaming the data in a single pipe. So if I talk in a general or our regular terminology, right? So assume that you have a water pipe, right? When I put a water from one end, so the water will flow to the other end. So wherever you have the taps, the water will pump from there, right? So there, so the pipe, right? It is a single pipe, the stream, it's a connected. All of them are connected. You will not have any disconnections. If it is a disconnection means it's a broken, right? So there you will not have a connection. So even using the stream API, the methods or the operations are connected together. Okay. The stream API provides some of the operations called intermediate and terminal operations. Okay. Intermediate and terminal operations. Intermediate, you can perform a multiple intermediate operations. Okay. So the stream, so we are not breaking. So this is nothing but the functional code or a fluent code. Okay. This is nothing but the functional code or a fluent code. Okay. So where we are iterating the data as a single stream. So we are not breaking it. Whereas in the for loop or while or, the iterator or for each loop, so we are breaking it. See, we are breaking the statements. The first statement in line number 16. So we are saying, so initialize from 0 to the less than the list dot size. And then every time we are doing the post increment. And then the next condition, we are again checking if it is less than 0, right? And manipulate 2, multiply by 2, else just print it, right? Again, it will go back to this loop. Whereas the stream is not like that. Stream is going to stream the data and process it by performing some of the intermediate operations. So here the intermediate operations, for example, the filter. Filter is similar to the if condition, you can say, and then transform it. Okay. So here we are just trying to manipulate the data. Okay. Even before that, so here this one is the lambda expression. This hyphen and greater than symbol is nothing but the lambda expression. Okay. So even before this, I will show you something with the interface. Then we will again come back to this. Okay. Definitely at this point of time, you are definitely blank. So we'll go back to the interface example, whatever that we discussed. And then we'll slowly write a functional interface. And then again, we'll come back to this one so that you will understand better. Okay, so let me write the functional one interface, and then we'll make it as a functional interface. Okay, we'll slowly understand what is a functional interface. Okay. So if you remember the previous example for the store card. So the store card has a multiple implementations. One is the Whole Foods and another one is the Amazon Online. Not this one, the Amazon Online, right? So both are which implements the store card. Okay. So what I will do is we'll convert the same thing into the functional interface. Okay. There are definitions for the functional interface. So the functional interfaces should not have a one abstraction, more than one abstraction. Okay. So by default, wide usage means it is an abstract method. That is what we discussed yesterday. Public abstract wide usage. That is the default, right? So we are not going to add, if you are writing even one more method signature, let's say wide display, meaning you will have to implement it. See, you're getting errors, right? You go to both the classes, Amazon Online and the Whole Foods, and then you have to override that particular method, right? We have to override. Similarly, you go to the Whole Foods, again, you will have to implement, right? You will have to override that method. Then only you can write the implementation. Why? We are enforcing that particular interface to have two methods. Since the classes which are implemented from the store card, so we need to override these methods. Okay, that's the reason you should be very careful when you're modifying the interfaces in the real time. If you are adding one method signature means that will be impacted all the implemented classes. Okay, if it is really required, but most of the real-time cases, okay, so we have something called a service layer. The service layers, they will have only one implementation. Those kind of a cases is fine. When you have multiple implementations for the interface, you should be careful. So that is where you should understand how many implementations. So if you are using IntelliJ, it's easy to identify. If you are using Eclipse or STS, it will be little difficult. That is where you have to search for usages. You right click, okay, you will find something usages or references, then you will identify. Okay, but in case of IntelliJ, it will show there are 4 usages and 2 implementations. Okay, so now, so you understand, right? So we should be very careful when you're modifying the interface. So now we are talking about the functional interface. The functional interface should not have a more than one method signature. Okay, should not have a more than one method signature. So for example, we are, for the whole card, for the Whole Foods and the Amazon Online, we are writing a separate implementation classes, right? We also discussed on the classes and something similar to the inner class, right? I was creating about, something employee or organization, something, right? So that's inner class, right? And then there is something called anonymous class or anonymous function. Okay. No, I'm in class. Yeah. So there is something called anonymous. Let me create a anonymous class or anonymous function. Then you will understand. Okay. After that, we will jump on to the functional interfaces. So let's say the store card. Okay. I'll say function. Okay. Let's create a main method. Now, here, I don't want to have a separate implementation class for this particular store card. You're getting it, right? I don't want to create a separate implementation class for the store card. Okay. I want to have an anonymous function. Okay. When we say anonymous, I'm going to create a reference for the store card. Okay. Whole Foods store card. equal to, we have something called new store card. See, this is nothing but anonymous. You see here, I am creating a new object. We remember we discussed you cannot create a new object for the interface, but this is not a creating an object. This is nothing but creating an anonymous function. Are you getting confusion? Anyone? Sahiti, Triveni? You're able to follow or no?
Can you explain me one more time?
Yes. Yeah. Yeah. If you don't understand anything, you stop me immediately, because this is very important. Most of the code in the real time nowadays, you will see at least 80 to 90% of the applications are the functional programming. I mean, people are trying to migrate it. Okay. Yeah. So if you remember, yesterday, we created an interface for the store card. And we have two implementations. One is the Amazon Online and the Whole Foods. So here we are writing a separate implementation class. So maybe we have a lot of business logic, and I wanted to separate them, both the Whole Foods and the store card. Okay. So we are writing a separate implementation class that looks good. Okay. Now what I am thinking is, why should I create a two separate implementation classes? Rather than creating a two separate implementation classes, I can also make it as an anonymous functions. Anonymous. Okay. Instead of creating a separate Amazon Online and Whole Foods, so I can directly say store card and a Whole Foods store card. Okay. And a new interface. What is an interface? The store card interface. And then generally, if it is a class, we'll put a semicolon. Since it is anonymous, curly brackets. Okay. And the same, whatever that we are writing in the store card, these things, void usage, public void usage, which is overrides, and again, public void display, which again overrides. Then you write your own implementation here, whatever. Okay. Let's say you want to pass a parameter. Let's say int discount. That is what we discussed, right? So if you want to pass int discount, you will have to change here. You have to pass int discount. Okay. Since we don't have that, so let's not pass anything. Okay. Let's say we apply 10% discount. Okay. Let's say discount applied. Okay. This is for the Whole Foods. Let's say I want to have a different implementation for the Amazon Online. Amazon Online store card. We apply 20% discount applied for online. Right? So now we have a two anonymous functions. Nothing but we already provided the implementation without writing a separate class. Right? This is the other way. This kind of code, even we never seen in the past. Very, very less cases. Very, very less. Okay. Hardly, I don't think so, even 1%. But some people, they used to write. I mean, it was the passion. Some people, right? So definitely, this is a good code only. Okay. Instead of writing a lot of implementation classes and all. Okay. But no one was comfortable at this that time. Okay. So now the same thing is possible with the functional interfaces, but the functional interfaces has a thumb rule. you cannot have a more than one method signature. One method signature, when I say one method signature, more than one abstraction is not possible with the functional interfaces. So this particular interface, we don't know whether it is functional or not a functional interface. So now can we treat this interface as a functional interface? Or no? Can we treat this store card as a functional interface? No. Okay. Why?
It should have only one method signature, either usage or display method
Okay.
signature, and yeah.
Yeah. Let's say if you want to enforce this as a functional interface, what to do?
You have to use a functional interface annotation.
Right. Now, I want to enforce this interface to make it as a functional interface. We have an annotation called @functional interface, but this is an optional. Okay. If at all, if you want to enforce, use this. Otherwise, you just always create only one method signature so that it will always treat as a functional interface, so that it's not a mandatory. If you want, you keep it, otherwise remove it. That's okay. That's not a mandatory, right? Now we'll get a compilation because we are trying to override. It doesn't have the abstraction method in the parent class. Sorry, in the interface. Okay, let's remove this. Okay, so now here also in the anonymous function also, let's remove it. Right? Anonymous function also, let's remove this. Now, I want to convert this into the Java 8 functional programming. I want to convert this into the Java 8 functional programming. It's a very simple. Okay. So now the same thing we can easily convert into the Java 8. How? Let's take the store card. Okay. I'll say Java 8 whole card, whole foods. Okay. I'm writing in a simple way. No, Goma. I mean, yeah, sorry. So now I'm going to use the Java 8, the functional programming. Okay. So that is where even before Java 8 supports the functional programming, the other languages, even Java inspired by the other programming languages like, Python, Scala, and Golang, it all supports the functional programming. Java was the one, which supported the functional programming last. Okay. Now, how can we make it using the functional programming? So here, how many methods we have? Only one method, right? That syntax is something like this. Usage, I will remove one by one slowly. Okay. So we need to have a usage and then lambda, right? And then system.out.println. Okay. Whatever that you are writing here. Okay. So it will be something like this. Yeah, I didn't make it 100% completely here, just to make you understand. Okay. Now, see now. But how can you understand whether it is the usage method or anything? Anyone? How do you understand? So which method you are calling? Triveni, Sahiti, any guess? Sahiti, you're there? Sahiti, Triveni, you're there or no? You can hear me, right?
Yes, yes.
Yeah.
It's from day.
Okay. Yeah. Any guess? Here, I'm not specifying which method.
From the main method.
No. It's not a main method, right? So which function, which interface we are calling? Store card. So that's the reason. So I'm coming one by one slowly. See, first I'm writing as a functional interface. Sorry, anonymous function. And then slowly moving into the functional programming. Okay. If you see in the anonymous function, we are overriding a usage method. Okay. We are overriding a usage method. So the usage method, we are something writing, apply 10% discount. Okay. So now this anonymous function, why we are writing anonymous function? We are trying to, we are not creating a separate implementation class, and then we are making it as an anonymous function. Okay. Now, if you see this particular code, it is the same thing. It looks like the same thing. New. Okay. It will be like this. New store card. Right. And then at the rate override, public void usage. The same code, right? This is how it looks like. This one I'm converting into the functional programming. How? Because you don't need to specify the method as a usage. Okay, because it has a single method. That is what I'm expecting. Since it has a single method, you don't need to specify what method. It's always usage. It's only one method, right? You have only one method, usage, right? So that's the reason I'm just giving a brackets. It doesn't have any parameters. That's the reason I'm not passing anything. Just an empty method. Okay. And what is that we are expecting here? We wanted to print the statement system.out.println. System. Okay, println. This is what we are passing it. Right? Now, if you want to test it, whether it is the usage method or something, sysout, sysout is not required, right? Because this is here itself we have a sysout. Java 8 Whole Foods dot usage. To call the method, right? We have to call the method, then only you will get the response. Okay. We are just creating a reference for the store card. Right? Now, if you run this, you will see the same result. Okay. So this one I'm not calling anywhere. So, okay. If you want to call this one, whole food cards dot usage. This one, Amazon online store card dot usage. Right? So let's run this one. Yeah, if you understand this one, you will be able to understand the functional programming. At least, 10% you will be able to understand. Okay, we'll see the last one, which works. Santosh, you are able to understand?
Yeah, Ravi. I mean, I'm just trying to correlate with the normal business use case. Most of the time, the
Yeah,
either has a multiple methods. I mean, the multiple implementations, right? So the
right.
use trying to understand what leads to a functional interface, and then how many interfaces that we need to define. Yeah,
Right.
so
Yeah. Yeah. In all the cases, we cannot define a functional interface only when you have a single abstraction. So it is kind of, the single responsibility.
yeah.
Okay. Solid principles. When you follow the solid principles, where you have a single responsibility in the interface, then you can go for the abstraction. Then you can go for this particular functional programming. Okay. So yeah, there are a lot of cases in the application. So where you will have only one particular abstraction or the responsibility. So you go for this particular functional programming or the functional interface.
I don't really want to confuse other people though, but I mean, the functional interface is still does it can have the default method still, or else I mean just
Yes.
only one method.
No, it can have a default methods.
Okay.
Okay. So that is the, that is to retain the interfaces. If you Google it, they will say that in the interfaces, we can have a default methods. The purpose is to retain the interfaces or to support the backward compatibility.
I
Okay.
think by migrating from the existing abstract classes to the functional interface so that they can implement the functional programming, I think.
Yes.
Yeah, got it.
Yeah. Okay. Yeah, other people you will be able to understand. I mean, immediately you will not be able to understand everything, but try to correlate. Okay. So the interface and the implementation and the anonymous and then functional. Okay. Directly, if you see this code, you will not understand. So that's the reason I have to explain the implementation and then anonymous and then the functional interface implementation. Okay. So this is nothing but the lambda. Okay. This is nothing but the functional programming. So that's the reason functional programming, if you don't understand the legacy code, you will not be able to understand. So that is the issue for the new generation. So they don't know all the old code. A lot of people still they write this kind of a code, but they doesn't understand what exactly is this. Okay. Sahiti, you're there, right? I'm not hearing anything from you. Okay. I think she's not there. Okay. Yeah. So now let's talk about one more. We'll add some more things in the usage method. For example, the store card. I want to apply my own discount. Int discount. See, now it says 9 problems. We have to fix all of them, right? Wherever we have the usage, we have to pass this int discount. See, int discount. We'll change this one. Okay. Yeah, let's change the other implementations and then we'll come back to that. I'm just passing 10 some dummy value for now. Other two is just to fix the compilation. Int discount. Okay. So now, yeah, coming back to our example, right? So this is where let's pass the int discount. Okay, let's pass the value 10, but even though we are not using this one, okay, int discount. Okay, yeah. So now what we do is, so here, right, we'll append this discount. Yesterday, we have seen some examples. Discount. Okay, discount. So now, here we have to apply the discount. How to apply? We have to apply this discount, right? How to apply it? Okay, so here we have to pass the value. But here, what is that? So you can say just a discount. Okay, so you can pass any name. You can say I or A, B, C or whatever. But finally, what is this? That is nothing but the discount. Okay, now do plus plus discount. That's it. So when you call the method only, we are passing the value. So here we are not passing the value. Okay, this is just a declaration. What is the variable? It is the discount. That discount we are appending here. And then we are passing the value when you call your method. So now what happens when you say Java 8 Whole Foods dot usage, which is going to call this and pass this value 10 here. And then that 10 you are going to apply it here. So using the Java 8, the Lambda and the functional programming. Now coming back to the definition for the functional interface or functional programming and the lambdas. Okay, so the Java, the functional programming, when you have a single abstraction, so we can use the Java 8, the functional interfaces. So which is going to reduce the code and also, so we can use the lambdas to simplify the, the method call. Okay. And with the functional programming, so the better way of writing the readability code, right? So that is what we have done here. Okay, you no need to create an object. It is just a function. See, we are not creating an object, right? Nothing. Even anonymous function also, it's not creating an object. Is it? No, right? So we are anonymous function. So we are not writing a separate implementation. If you are writing a separate implementation and creating an object, that is creating an object. But here we are not creating any object. Right? See, it also suggests, since we created the anonymous function, it says that replace with the lambda. Right? Here, see, it is showing just a gray color, right? When you mouse over, it will say replace with the lambda. So this is nothing but the functional interface and the lambda. There are some predefined functional interfaces. Okay, so if you go to the official documentation, Java 8 functional interfaces. So if you go to the official documentation, the Oracle, see, these are all the predefined functional interfaces. Okay, we have something called a function, by function, consumer, by consumer, predicate. There are a lot of other things. Most of the interviews, they will ask, what is a function and what is a by function? What is a consumer? What is a by consumer? What is a predicate? Okay, so mostly they will ask these interview questions. So if you go to the function, the documentation, right? So the function which accept the input and result the function. Okay, the function, the type of the input to the function. T means type, R means return the result, the type of the result of the function. Meaning, so the function which is going to return, if you want to see how it is, so here also they have given a code, okay, and I'll show you here, shift control R, not R, shift control T, function. See, java.util.function. See the package, java.util.function. So this is the functional interface. They're enforcing this function to make it as a functional interface. This is nothing but the generic type. So meaning, so it accept T as an input, R as a result. See here. Anything right.
If I declare any object for this interface or an implementation for this interface, functional
Yes.
class, will that be in a public function or it'll be a private function?
It will be public.
Public, okay.
Yeah. Okay. So now we see here, the return is going to be R and the input is going to be T, the parameter, right? So it doesn't have any other method. See, these are all the default methods, default and static methods. But the abstract method signature is only one. This is nothing but the default abstract method signature. Okay. So meaning, so this particular apply method which is going to return something. Okay. So if at all, if you want to write your own functional, I mean, the default functional interfaces, you can use this one. Okay. And similarly, by function, which is going to accept two parameters by function. See, it's going to accept two parameters. See, T comma U. These are the two parameters and R is the return. Function by function. And we have a consumer. Consumer, it just consumes, but it doesn't returns anything. See, the consumer bit, it just accepts it, but it doesn't return anything. Void means it doesn't return anything. Void means it doesn't return anything. Consumer. Okay. Similarly,
Kind of a logger method implementations. Probably.
exactly. Yeah, because logger method, we don't return anything. We just print the display statement, the log.info, debug or whatever. Okay. So we have a by consumer. Okay. Yeah. So by consumer. So similarly, the consumer, by consumer also, it accepts two parameters and it doesn't return anything. Right. And so these are useful when we talk about the stream API. So that's the reason I'm just showing all these things. And we have something called a predicate. Okay. So predicate, is it a predicate? Yeah, predicate. Okay. So which just evaluates and returns. I think this is not the functional interface. Sorry. Is it a function? No, that's a different predicate. So yeah, this is the one, second one. Okay. So yeah, you can see. So it has a test method which just return a true or false, which accept one parameter, one argument, and returns true or false. This is the predicate. Okay. Consumer, which just accept, and the function which applies and returns true or false. Consumer, it doesn't return anything. Predicate, which returns true or false. These are the predefined functional interface. Most of the real-time cases, we use only the predefined functional interfaces. Very rare cases, we create a functional interfaces. Very, very rare cases, we create a functional interfaces. Okay. Because, most of the real-time cases, we will have a multiple, the methods, right? So that's the reason we always use the predefined functional interfaces. One of the example that we were talking about, the list test. Okay, you see here, map. What is the map which is accepting? If you just mouse over, so map which is going to use the function. Function, what is the definition for the function? Which takes one parameter as an input and returns the output, or, right? So now that's the reason I had to talk about all those. What is the functional interface and what is the lambda? What is the function, by function, consumer, by consumer, and predicate, right? Now, if we come back, they will ask these kind of interview questions. What is the filter which accept? What is the map? Okay. So what functional interface map takes? Okay, these kind of interview questions. So the people who understand the functional programming very well, they will ask these questions. Right? So now if you see this particular map is an intermediate function. In the Stream API, intermediate operations, not intermediate function. It is an intermediate operations. See here, the definition says returns a stream consisting of the results of applying the given function to the elements of the stream. This is a intermediate operation. Okay, the original definition, we can say that this map is for the transformation from one object to the another object. That is where we take the input and return to the another object. Okay, this is just one example. I will show you a couple of other examples so that you will understand better. Any questions before I show the another example about the Stream API? Triveni, any questions?
No.
Okay. What about you, Gajendra?
No, sir.
Okay.
I'm good.
Yeah. So now let's create another example. Okay. So I'm going to create an employee class. Okay. So employee, and let's say private int employee ID. Okay. So observe carefully. I'm creating only the primitive data type. Private string, let's say employee name. Private string department. Private string address. Okay. Let's generate the setter getters. So go to the generate. Setter getter, choose everything and okay. So now I have a setter getters. Okay. Now I'm going to create a employee test. Okay, let's create a main method. I'm going to create a employee objects. What I will do is I'll also create a constructor because I cannot write a multiple times setter and then set it. Okay. I'll also create a all argument constructor. I'll also create a default constructor if it may be required. It may not be required. So I'm just creating it. One is no argument constructor. Since I'm overloading this. So I had to create one more constructor because by default, it will have the no argument constructor. Since I'm writing the all argument constructor, so I wanted to have one more default constructor. Okay, it may not be required, so I'm just creating it. Now I'm going to create 4 different employee objects. Employee E1 equal to new employee. Okay, so one is the employee ID, one employee name, let's say Ravi, department D1, and address, let's say NJ1. Employee E2, okay, let's say NJ. Let's say Veera, department D2, and employee ID 2, let's say TX. I'm going to create one more employee object, employee E3. These are different employees, right? So 3, let's say Shankar, and D3, let's say CA. Okay, let's take only 3. Okay, let's say, yeah, we'll also create the first name and the last name. Okay, F name and L name, private L name. Okay, let's change it to as a F name and a string L name. L name, L name. Okay, so I'm going to generate this setter getters again for F name and L name, because the reason that I'm including first name and last name, generally, even if you go to the any registration page, you will have a first name, last name, middle name, and all, right? I wanted to filter the employee's last name, something, or let's say employee's salary. Let's add the employee's salary also. Private. Let's take as the integer only, salary. Okay, so let's pass the salary also here, int salary. This dot salary equal to salary. Okay, so let's generate a setter getters for salary also. Setter getter salary. Okay, so now we need to have a first name and a salary. Sorry, first name is Ravi. Let's say last name is Karla. Okay, and then salary, let's say 1000. So first one is fine. Let's say again, I'm giving the same last name. Let's say some 5000. Okay, let's take the last one as some test as the last name, and the salary, let's say 10,000. Right now I have 3 employees. I want the last name is a Kakarla. I want to get all the employees. The last name is a Kakarla. First of all, I just created only employees. Now I have to convert this into the employee list. How to convert it? In real time, you may not be creating these many objects. Okay, that you will understand when we talk about the Spring Boot application. Nothing to worry at this point of time. So I'm going to take as a list of employee. So the type is the employee. this is the employee list equal to arrays dot, we have something called as list E1, E1, E2, E3. Okay. I'm just converting these employees into the list. Or else you can also do new array list, employee list dot, we have an add method, E1, employee list dot add method, we have a E2, employee list dot add method, we have a E3. Right? So in traditional way, if you want to filter all the employees ending with the Kakarla, what you can do, you are going to write a for loop or for each loop, and then you are going to write a if else condition. If you are going to write a for loop, int I equal to 0, I is less than employee list dot size, and then I plus plus. So if employee list dot get of 0 dot equals ignore case or equals, it has only equals. So let's say Kakarla, and then you're just going to get all those employees list. Employee list dot get of 0. So this will just gives all the employees, whose last name is Kakarla. What happened? Didn't print anything. Oh, sorry, not get of 0, get of I. Okay. Still didn't print anything. Did I do any mistake? Oh, sorry, it's not this get of I. Strange. Did I miss something? Oh, we're not printing. Is it anything? So get off Y. Yeah. Let's do one thing. We'll write a toString method. Okay. So let's generate a toString method. Or you can also print whatever the data that you require. I think something I'm missing. Otherwise, at least it would have, it can even print the hash code. Go. Yeah. So employee E1, E2, E3. Okay. Employees I'm adding into this list, and then employee list. I'm iterating. Get a phi.
It'd be using some not a equals right there. It's an object. Object you are comparing with an equals.
Yeah. Sorry. Dot get last name. Yeah. Get last name. Okay. Yeah. So yeah, equals ignore case we can write. Equals ignore case, even if it is the case sensitive. Okay. Yeah. So now we get all this employees list. Right? So employee ID 1 and employee ID 2, you can see it is matching. So with the same thing with the Java 8, so you don't need to write this much of code. It's a single line with the stream API, you will be able to write it. Employee list dot, we have a stream dot, we have something called a filter. Okay, filter which uses the predicate. If it matches, then only it will return. That is where, right? So if you see the predicate function, see, it returns true or false. It takes the input and returns the true or false. Okay. So now what is that you want to filter? The employee EMP You can write anything, EMP or employee or whatever. EMP lambda. Okay, so EMP dot get last name dot equals ignore case, whatever that you want to filter, and then either you can collect it. So this is the terminal operation. Once you collect it, you cannot do anything. Okay, collector star to list. Meaning, again, I am converting into the another collection. Okay, or if you just want to print it, you can write a for each. Okay, let's collect into another collection. So when you collect into another collection, so you will have to write a, the return type, list of employee, result employee list, result employees, right? Then now we can print it if you want. See, you're getting the same thing, right? But as a list. If you don't want to, generally, this is how we write it. If it is only for testing, so even you don't need to collect it, you can write a for each system dot out colon println. This is something called a method reference that we call. Okay, so if you are writing like this, you don't need this one. Right? I would recommend always collect it and then get it, whatever that you want. Right? It's a very
When do we use that? I forgot that. I mean the method reference, that the 3 column thing.
right. Yeah. So method reference basically it is another the map and all, we can use the method reference. I'll show you that example also. Okay. In the map, right? So let's say you want to get only yeah, I'll show you the another example, then you will understand better here only.
That's right.
Yeah. So let's say I want to get only the last name. Okay. So here the employees, yeah. So the same example, right? So if the employee's last name is a Kakarla, then I want to get those names. I want to get only the employee names. Only employee first name if the employee last name is a Kakarla. Okay. So then what I can do is we no need to return the list. Okay. String, list of string.
బా ఏమనిపిస్తుంది
Gajendra,
నేనే పెడితే
Gajendra, can you go on mute? Gajendra,
ఏంది బా
Gajendra, mute. Yeah, okay. So now the another thing. So let's say I want to get only the employee first name if the employee last name is Kakarla. So what we can do, we have a map transformation, right? Map. So which is going to accept the function as the input and return the result, right? So EMP lambda EMP dot get last name. This is what generally we write it. Instead of writing this by using the method reference, because I can directly get using that employee reference the last name, employee colon, okay, get last name. Sorry. Yeah, employee dot get last name. By using that particular employee object, I can get the last name. So this is the method reference. Okay. So I don't need to again define the employee as an input parameter and get the employee last name. Rather than getting that, so you can use the method reference by using the employee class itself. and then use this the double colon, not a colon, sorry. Yeah, colon, yeah, double colon operator. That is the method reference, and get the last name. Right? So now if you run it, you will get only the last name. Sorry. Yeah, here you will get only last name. I want first name actually, first name. So this is nothing but the transformation. Filter is for filtering and map is for the transformation. Converting from one object to the another object. Employee object we are converting into the string. See, basically, I have the list of employees. I'm converting into the string, list of strings. What is the list of strings? I just want to get only the employee first name. So this is where we use the transformation and use the method reference. You got it, Santosh, now?
Yeah, I think about this. If we are directly just kind of a transforming to the one of the that is object property, I mean, then I think we can use.
Yes, we can use the method reference. There are multiple method references. So we have the static method reference, and yeah, we have a constructor reference, I think. There are 3 or 4. Yeah, one is the instance and the constructor and the static. I think 3 or 4. I need to check that. Okay, so this is the instance. Okay, so Triveni, you understand now?
Yes, I understand.
Yeah. So now definitely you will be able to at least, going forward, you will be able to understand how to write this code and all. Right? So when you have this kind of a code, at least you can understand. So what is going on? Okay. Yeah. Practice couple of examples so that you will understand better. You create this kind of application. Simple example, employee list, and try to filter, try to get it, try to, uh, get the employees only salary, or employee age is less, greater than something. These kind of examples you can write it so that you will
Okay.
understand better.
Okay.
Yeah, we have so many other operations. So filter is one and map is one. We do have a flat map. We do have so many other methods are available. So right now we are just collecting into the another collection. Collect of collectors.toList means we are collecting into another collection. You can also collect into the map also. Let's say I want the response as map of integer and employee. If you want to collect it this way. So these examples, these scenarios are very common. Maybe I'm getting from other API as employee list, but I want to return the response as a map of integer comma employee, meaning this integer is nothing but employee ID and employee, so that I can easily correlate it. If I want to get some particular employee, I can directly get it. Otherwise, every time I have to iterate, right? The difference between the getting a filtering list and getting an employee and using the map. Map is easier way, right? If you know what is the key, it's easy to get it, right?
Yeah, it's
So,
about performance each and every time whenever.
yeah.
Right.
So if you have a list, this kind of a list, you will have to iterate each element and find it where is the employee ID and then get the employee list. That's going to be tedious task, right? So employee object. So if you know what employee ID, just pass that key and get the value. Simple. Okay. So any clarifications on the list? Yeah. So as of now, we discussed on the list how to add it and how to iterate it and how can we use the Java 8 Stream API. Okay. Let's say you want to remove a specific employee from this particular list, right? So we have something called result employees dot. We also have a remove operation. Okay. Remove what object and what key, what index. Let's say if I want to remove the first index, means 0. Index position is different, size is different. Index position starts from 0 and size is always 1 to 2. Okay. So the resulted list size is 2, but the index starts from 0, 0 and 1. Okay. Now if I remove and if I print this, okay, after this again, so you will get only one employee. Let's run it. See, because we are removing the first index. Okay. So yeah, this class we talked about, we spent a lot of time for the collections to understand and what are the different ways we can iterate and if condition, else if condition, else condition, right? So I would recommend to practice the linked list example. We discussed on array list. You practice the linked list and try to understand the difference between the array list, linked list. There is one more thing called linked hash set. Okay, practice the linked list and linked hash set. Okay, the other definitions for the array list. Okay, so array list we can add the elements and we can remove the elements, and list allows the insertion order. It allows the insertion order, or insertion order is preserved. Order is preserved. Right? Meaning whatever the order that you are inserting, it will be in the same order. Okay. So, and one more thing. So it has a load factor and all, but you will get a confusion at this point of time. So no need to worry. Slowly, when you're comfortable writing all this code and all, you understand how the internally array list works and what is the load factor. Okay. Those things, slowly go through it, not at this point of time. Okay, so when you go to the next level, when you understand all this programming, how to write it, then slowly go to that level so that, those questions will be useful when you attend the interviews again. Okay, so now let's quickly talk about the set also. There is another thing called the set. Let's take the same thing with the, same example you may not understand. So let's create a set example. Okay, first I'll create one is a list here. One more time, list of integer, list equal to arrays dot as list. Okay, 1, 2, 3. Again, I'll create a 1, 2, 3. Okay, or let's define some random numbers. Let's say 10, 1, 2, 10, 2, 3. Okay, print this list. Yeah, I'm also creating another one, set interface. Set, let's take a same integer, set equal to. So this one, what I can do is, I'll copy the same thing, but yeah, there is a different way of transforming, but for your understanding, so what I can do is I can create a new hash set. Hash set. Okay. So we can also pass this list. This is one way, or the other way. Set dot add. Same. Similarly, we added for the array list, right? Same. Set dot add to set dot add 3, and again add set dot add 10 set dot add to set dot add 3. So now if I print the second one set and the first one list basically it allows the insertion order, whatever the order that we added. That is one thing. Second thing is it allows the duplicate elements. Set basically the order is not preserved. There is no guarantee on the insertion order. Okay. And it doesn't allows the duplicates. It doesn't allows the duplicates. Okay. So let's run this. See, even order also it's not preserved. So we are inserting the order 10 2 3, but we are getting 2 3 10. There is no order guarantee, right? And it doesn't allow the duplicate elements. See, there are no duplicates, right? So this is the main thing. Okay. So hope you understand the difference between the list and set.
So
So
set is 2
Yeah.
3 10, right?
Yes, yeah, 2 3 10.
Okay.
Yeah, it doesn't allow the duplicates. And there is no guarantee on the order. Okay. So that's the reason I suggested you to practice and understand the difference between the linked list and array list and linked hash set. Okay. Linked hash set. Some of the cases we use the linked hash set. So that's the reason. Try to understand the linked hash set. Okay. So if you have any questions or if you are not able to understand, let me know. I will talk about these things also. Okay. So it's clear, right?
Yes.
Okay. So yeah. So now even for the set also, you can use the same, set dot stream, and then whatever that you want to filter, or let's say filter some value is greater than, let's say 5. Then collectors dot to set. Or if you want to print it, for each system dot out : println. You can use the method reference. So here it is just a static method reference. See? So we are writing a condition if the value is greater than 5. Right? So this is how. We also have something called so
Sort of will work.
yeah, even sorting also there. Okay, if at all if you want to sort it, you can also use the sorted. Sorted. Let's comment this one. This one. Right? You will understand it. Sorted. It will sort it. Okay. So if you go back to this particular employee test, okay, what I will do is I'll copy the same employee as a employee 4. E4. Okay. Now what I will do is I wanted to compare sysout E1 dot equals of E2. What is the expected response? Sorry, E4. E1 dot equals of E4. It is the same object. You see here, 1 Ravi Kakarla D1 NJ 1000. Here also E4 also same. Anyone, can you tell me, is it a true or false?
I think it falls.
Why?
Yeah, in Java, every class is implicitly extend the superclass. Sorry, yeah, object, right?
Right. Mm.
Internally, yeah.
Right.
So we have their equal method and hash code method. So those are we have to do manual implementation, customized employee class.
Yeah, that's true. Yeah. So the E1 and E4 are different objects. Okay. It will have a different hash code, even though the employee E1 and E4 are the same. So you are getting the different, right? So basically here the values are same, but it will return false. Let's run it and how to fix that. See, it says false. So even though the objects are equal, but it is giving the false response. Response as a false, right? So what is it we need to do is we will have to override. There is something called hash code and equals method. Okay, that you will understand when we talk about the map interface. Okay, generate equals and hash code. Wait, go back. So okay, let's go with the Java 7 plus only. Okay, so now let's run this again. See, now it is returning a true. Okay, you will understand better that one equals and hash code during the map discussion when we talk about the map. You got it, right? Okay, so lot of applications definitely will see this hash code and equals methods overridden. Or if you are using Lombok, you will also see @data. Okay, @data will have a setter, getter, toString, hash code and equals also, I guess, and the argument. I think all argument constructor and no argument constructor. I think equals and hash code will not be there. There are cases where you will see @equals and hash code. Okay, so is it clear? Okay, so yeah, try to understand all these things. It will be easy, and slowly we will jump on to in the next class, we will talk about the map and exception handling. Okay, and some of the threading related examples. Threading definitely you will not be able to understand, but we will talk about very basics on threading. And most probably in the next week only, we'll slowly start the Spring Boot. That is where we will spend more time on the real-time applications and what are the different features and all. Okay, so that you will be comfortable writing code and understand the code. What are the different annotations, everything. Okay, we'll also talk about the microservices, some definitions on microservices, everything. Okay, I would recommend spend a whole this week and practice couple of examples on the collections and all. Okay.
Okay.
Yeah, that's all. Then I'll upload this video in some time, in another 1 hour, so that it will be there in the same location.
Ravi, I didn't got the email.
Oh, okay. I'll trigger again email. Yeah.
I'm just
Did you check the spams also?
yeah, I checked the spams also.
Let
Just
me
putting in the one more.
let me check right away.
I should understand.
Yeah. I copied. Did you ping the email ID? Yesterday you shared, right? Same thing, right? Yeah.
Yeah.
Let me show you what is the email ID that I entered. Code Java 2024.
Yeah.
This is the one, right? Okay. I'll delete and re-trigger again. Remove access. I'm going to add again.
Okay, let me check that directly to the Drive, Google Drive. So
Yeah. So it should be there in the Google Drive, or you will get an email, from info@runningtechnologies.net. So it may be the spams.
I check the directly Drive.
Yeah. You can search with this email ID also. Yeah.
Yeah, I got it.
Yeah. Okay, then. Yeah. So let's meet again in the next week. And until then, so please spend some time and practice all these things. Okay, then. Yeah. Thank you.